So hopefully by now you're a little bit more comfortable in solving simultaneous equations using the elimination method. But what I'm going to do is solve some harder examples. So maybe you'll see some stuff you haven't seen before, and we'll come up with strategies on solving our simultaneous equations. So here we have two equations, equation 1 and equation number 2. Now, by now, hopefully you've figured out that you're like, hang on, if I've got signs that are different, I need to add them. So here I've got like an x and a negative x. I know the signs are different, and that's just a 1x, and that's a negative 1x there. So I could add them. But on the flip side, when I have signs that are the same, I could also subtract. So here we actually have two options, and it doesn't matter which option you do, both will actually give you the right answer. What I'm going to do here is I'm going to subtract equation 2 from equation 1. So what we're going to start off with is this equation here. We've got x, and because we can kind of go, hang on, like there's like terms here, what we're really just doing is we're doing the whole x plus 2y minus x plus 2y. But then when we have x minus x, that will turn into a 2x. We have 2y minus 2y, that will cancel out. And so what we have on the left-hand side is just 2x remaining. And then we're also going to do 4 minus 8. So 4 minus 8 is negative 4. And then we have to just solve this equation, which means we're going to divide 2 from both sides. And so our x is equal to negative 2. Now, if you had decided to add the equations, you would have had to solve y. But what we just did instead is we solved x first, then we found y. If you added the equations, you would have had to solve y, and then find out that x equals to negative 2. So when our x equals to negative 2, we need to sub in x equals negative 2 into either equation. I'm just going to sub it into equation 1. So negative 2 plus 2y equals to 4. And then you're like, hang on, to get rid of a negative 2, we need a plus 2, so 2y equals to 6. And then divide both sides. And then we end up with y equals 3. So what we were saying before is if you just substituted, added these equations, what we said before, if you just added these equations and found that y equals to 3, and then you substituted any of these equations, you would then get x equals to 2. But what we just did is the other way around. Okay, so I'm going to do another example. Where we have 5x minus y equals to 1 and 3x minus 2y equals to negative 5. Now here we have a similar example to our substitution method where these numbers aren't actually the same. So what we have to do is we need to manipulate the equation slightly until we can end up with a number in front of our pronumeral, our letter, that is the same. So one way of doing that is I could times this whole bottom equation by 5 and this whole top equation by 3, and then I'll have 15x on both sides. But easily I could just double everything in equation 1. So equation 1 then looks like 10x minus 2y equals to 2. And then I've got 2y and 2y. When the signs are the same, we can subtract them. So what I'm going to do is subtract equation 2 from 1. So 10x minus 3x gives us 7x. 2 minus 2y minus 2y will give us 0. 2 minus 5, you got to be careful here, because if we're subtracting minus 5 from 2, that would be 2 minus 5, which gives us 7. And then we just divide both sides by 7 to find our answer. Now at this stage, you'll notice that most of our answers are whole numbers, alright? Sometimes they could be fractions, but I think for the worked examples, none of them will be fractions. Okay, sorry, I forgot to move the camera again. Once we found that x equals to 1, the thing now is we have 3 equations we could substitute them into. It doesn't actually matter which equation we sub in. It'll work when we sub in x is 1 here, it'll work when we sub in x is 1 here or here. So let's just go with our easier one. Sub x equals 1 into our first equation, and then we get 5 times 1 minus y equals 1, 5 minus y equals 1. We could just figure out that 5 minus 4 equals 1, or we could minus 5 from both sides, and then times by negative 1 until we get the same answer as well. And so here we have x equals 1 and y equals 4. Now what I forgot to do in the previous example was substitute these in and double check if it works. So if we go minus 2 plus 6, does that equal to 4? Yep. So we're happy with this equation. We also substituted in this one. Minus 2, so that's 2 plus 6 equals 8. It works for this equation as well, which is why this is our solution. So if we do that for the following ones down here, 5 minus 4 equals to 1, right? And it should have worked because that's the equation we substituted into originally. 3 minus 8 equals negative 5. Works for this one as well. And just to show you that this would work for this equation here, which we've just doubled, 10 minus 8 does also equal to 2 as well. So x equals 1 and y equals 4 are both my solutions to that problem. So we're going to just do one last example together, just to make sure we know what's going on. So 3x plus 2y equals negative 5. And this one's going to be a little weird because it's going to look like 4x equals 3y minus 1. Now, when we look at this problem, first of all, we notice several things. One, the letters are not all on the same side. What we could do is just minus 3y from both sides to make our equation 2 look a bit nicer. But instead, I'm not going to change anything and show you how we can just solve this without that. So again, we have the same problem where our x's and our y's don't equal the same thing at the moment. So what we're going to do is we're going to actually just times this side by 4 and times this side by 3. Now, the thing about this is we know that 12 is a multiple of 3. What I mean by that is that 3 times 4 equals 12. And we also know that 12 is a multiple of 4, because 4 times 3 also equals 12. So what we're going to do is, that's why we're deciding to times all this top equation by 4 and this whole bottom equation by 3, because when we times the whole top equation by 4, we end up with 12x plus 8y equals negative 20. And our bottom equation, we get 12x equals 9y minus 3. But the thing about now is we have a pair of terms which are the same size. And if you remember, when the signs are the same, we need to subtract. So let's call this equation 1 and call this equation 2. So we're going to subtract 2 from 1. So what that looks like is we have 12x minus 12x. That's going to be nothing on that side. We have 8y minus nothing. So girls, remember when we have the left-hand side and the left-hand side for these two equations, where that's what we're subtracting. So we're just going to have a plus 8y here. We're going to have nothing minus 9y, so we're going to have a negative 9y on this side. And then finally, we're going to also have minus 20 minus 3. Now, what I would suggest is when you type this in your calculator, you won't make any mistakes. 20 plus 3 gives us minus 17. Okay, it's really tempting to write minus 23, but type that in your calculator, because we're doing this minus that. Now, what we've got now is just, let's make that look a bit nicer, is 8y minus 9y equals negative 17. So to solve this, we need to just move the 9y to the other side. Then we end up with 17y equals negative 17, and I think you can see where this is going. I'm going to divide both sides by 17, y equals 2, negative 1. Alright, So we found one of our solutions. Now we're going to substitute this back into any of our 4 equations. If we substitute it in here, it'll work. If we substitute it in here, it'll work. If we substitute it in here, it'll work. All these 4 solutions will give us the same answer for x. Now, the reason I would suggest you pick these ones is because timesing something by 2 and 3 is a lot easier by timesing something by 8 and 9. So, let's substitute into equation 1. It doesn't actually matter which one I substitute in. You can substitute it in any of these 4. You'll get the same answer. 3x plus 2 times negative 1 equals negative 5. 3x equals, 3x minus 2 equals negative 5. Plus 2 to both sides. 3x equals negative 3. Divided by 3 to both sides. X equals negative 1. So this whole equation was when x equals negative 1 and y equals negative 1. Now, we don't have to check this one because that's this whole substitution step. But let's just double check if that's true here. Does 4 times minus 1 equals minus 4? 3 times minus 1 equals minus 3. Minus 3 minus 1, negative 4 equals negative 4. So it works for this equation as well. And we can also check that minus 12 is equal to minus 9 minus 3. So it works for this equation here. And minus 12 minus 8 equals negative 20. So it also works for this equation up here. So that's why we can see our answer, our solutions to these simultaneous equations is when x equals negative 1 and y equals negative 1.